Okay, ladies, so I thought it might be helpful if I post on here sort of the sequence that you should follow to answer a standard Hardy-Weinberg question. So this is like we did in class, but hopefully maybe this will be a way for you to watch this at home. If you're working on your problems, then it'll help refresh things. What I'm taking a look at here is actually number 3 on your Hardy-Weinberg practice problem sheet. So if you haven't done that one yet, here's your chance to follow along. The first thing you want to do is you want to read the problem, and I usually like to put genotypes with it. So on this one, if dark eyes are dominant to light, in a population of 1,000 individuals, 360 show a recessive phenotype. So more or less we could say that this individual would be like little d, right, if those were the letters we were using. Then it wants us to tell them how many are homozygous dominant, so 2 big D's, and how many would be heterozygous. So we got big D, little d. Now, always start through a q-squared door. So step 1 is figuring out what is q squared, and therefore what is q. Now, q squared is the frequency of homozygous recessive, right? So q squared equal frequency of homozygous recessive, which in this case we can say is 2 little d's. And they've told us this, right? So q squared for this problem equals 360. And since it's a frequency, we do 360 out of 1,000. So that's going to give us 0.36 for our q squared value. Then we just take the square root of both sides, and that will tell us what q equals, which the square root of 0.36, we should get 0.6. So there's the first part of our solution, is getting to what q equals. Now notice, they could have given us a percentage, right? They could have said 36% of individuals are homozygous recessive, and we would have worked it the same way. We could have just skipped this step, basically. And there's a lot of ways that you can present that. Now, the second step that we want to take is to use the smaller piece of the formula, which is p plus q equals 1, to solve for p. So in this case, you just plug in that q value, p plus 0.6 equals 1. Subtract 0.6 from both sides gives us p equal to 0.4. Now, we know our p and we know our q, which means we can do the third part of the solution, which is to use the larger formula for Hardy-Weinberg and break it down into its component parts. So let's take a look at a new slide here. Okay, so thanks to our first 2 pieces of this, we know that q is equal to 0.6, and we know that p is equal to 0.4. Now, step 3 of solving the Hardy-Weinberg question is to use the whole equation, p squared plus 2pq plus q squared equals 1, and use that equation not as a whole, but for the parts that we really need. What they ask us for in this question is, first, what's the frequency of homozygous dominant, which is equal to p squared. So since we know what p is already, we can just plug in here. So p is 0.4. We square that, and that's going to give us 0.16. Now the question actually asks us how many individuals, and so we were told at the beginning that you've got 1,000 individuals in this population. So 0.16 times 1,000 means that 160 of these people will be homozygous dominant. So there's the first part of our answer. The second thing they ask us for is how many people are heterozygous. So heterozygous is the second part of this formula. So that is equal to 2pq. Again, we know p and we know q, so we plug in p is 0.4 and q is 0.6. That's going to give us 0.48. Again, we do that times 1,000 total individuals, and that's going to show us that 480 would be heterozygotes. Now, if you've got the time and you want to be real certain, you can double check your work, right? We're told that 1,000 individuals are in this population. We were told that 360 of them were homozygous recessive. We just solved that 160 of them should be homozygous dominant, and 480 of them should be heterozygotes. And so what you can do is you can make sure that that will come out to equal 1,000, which it should. Occasionally, based on rounding, you can come up with something that's slightly different, but as long as you're close, you can probably be pretty confident that you got the right answer. So hope this helps. Again, this is number 3 from your problem set, and you can apply these ideas to most of the other questions to help you as well. Good luck.